In this video I will show you a couple of calculations that can be done with ratio and proportion and how they apply to their various fields. Before we start anything, a fair warning that context is everything. You have to sort out given implicit clues from the context to decide whether it is a direct proportion or an indirect. That indirect proportion is also called inverse proportion. Okay, let's get started with an example from the culinary arts trades. We'll go for a recipe conversion. First one, recipe conversion. And I'm going to use the numbers from the previous one. A recipe says that for the 10 people, it serves 10 people. And for this potato salad, you gotta have 5 pounds of potato. Well, throughout these examples, I'm gonna change imperial or switch between imperial and metric amounts, length, weight, everything. I'm gonna change it up and make it versatile. So the recipe says for 10 people, you need 5 pounds of potato for a potato salad. There are 30 people coming. Question is, how much potato should be on the countertop? Enough for 30 people. And as this can be solved with ratio and proportion, I'm going to point out the obvious, but maybe not so obvious, that we have 3 given amounts. And like I said, there's always 3 given amounts, and there's 1 piece of requested information there. And from the 3 given amounts, and as they are related, we can work out the 4th amount. How does this work? You can write it up as follows. 5 is proportionate to the 5 pounds is proportionate to the 10 people, as the so many pounds are proportionate to the 30 people. Here we have pounds, and here we have pounds, and here we have people, and there we have people, and they are both proportionate. Now you can solve it 2 ways. One, you look at it as equivalent fractions. If this one is 5/10 and that one is something over 30, how many times did the numerator get increased? Well, it got increased 3 times. Thus, we have to increase the numerator here 3 times, because the denominator got increased 3 times. And 3 times 5 will be 15. So you can solve it this way. They work this way wonderfully well. Or you can solve it with a quick trick here. Multiply that amount with the total of that fraction. In other words, 5 divided by 10, which is gonna equal to 0.5. It gets multiplied by 30. 0.5 times 30, half times 30 is 15, but here it is. I place that on a calculator. There, 5 divided by 10 multiplied by 30 is 15, equals 15 there. So this is an easy way to solve this ratio and proportion problem, or recipe conversion problem with ratio and proportion. if you write up the original ratio and proportion, so the unknown amount is in the numerator there, you can just do one division here and then multiply the result with the denominator. That's one version that is easy. If you end up with the unknown amount written up last, you could have written, for example, the 5 pounds is proportionate to the unknown amount of pounds, because the 10 people is proportionate to the 30 people. Now you have the unknown amount in the denominator. And to solve this, you can also use equivalent fractions. The numerator amount from 10 to 5 got divided by 2. Therefore, the denominator amount must also be divided by 2. And thus we arrive to an amount of 15 for the 15 pounds amount. But you can also solve it with an equation format, but it's harder to see. The easy way to do it is to flip this one, and flipped up, this is how it looks like. So many pounds divided by 5 equals 30 divided by 10. And then what you can do is 30 divided by 10 is 3, and you times the 5 with the quotient of that division. 5 times 3 is 15, and 15 is the requested amount. So there's a couple of options here. You can pick and choose, and I usually try to write the unknown amount up here, because I know I can just do a division as it is written and one multiplication super simply. Let's do another one, which involves, we had rectangles and the amounts that I used in rectangles. Let's do one involving a ladder. Here is a wall, and here is some ground. Now a ladder to be properly set up and leaned against the wall like so. For every foot of horizontal distance, this is the ladder leaning against the wall. This is ground here. So for a ladder to be set up properly, we know that for every 1 foot of horizontal travel, the height of the ladder must go up 4 times. So that's a 1 and that's a 4. That's when a ladder is set up safely. 1 to 4. Now if the base of the ladder is pulled away from the wall, say 5 feet, the question is, to what height will the ladder reach? Again, this is a ratio and proportion problem. Please note that we have 3 amounts given and 1 amount is requested, the height, and from the 3 amounts we can work out the 4th amount. To do this, we have to compare the horizontal distance of 1 foot to the other horizontal distance of 5, and we can write it in 2 ways. The 1 is proportionate to the 5, and we can write the 5 here or here, it doesn't matter. How about we write it here? The 1 is proportionate to a 5, just as the 4 is proportionate to the height of the ladder. And you place your marks there, and we ended up with the unknown amount there. No problem, we can just flip it like so. Oh, sorry, my bad. So I said flip it like standard procedure, and now we can figure it out fairly easily. 4 divided by 1 4 divided by 1 gets multiplied by 5 to figure out x. 4 by 1 is 4. 4 times 5 is 20. 20 equals x. The height of the ladder that it reaches is 20 feet when the base of the ladder is pulled 5 feet away from the corner. Let's do one last one involving a circle. So how about if I grab this circle here, my handy dandy circle, and thereabouts we have ourselves a circle, and we are going to calculate arc length. For example, this circle has a circumference of 10 centimeters, and this one is a 45-degree angle here. The question is, how long is the arc? Well, like I said, we have 3 amounts, and the 4th one is requested. Here is 1 amount given, here is 2 amount given. Now, where is the 3rd amount? The 3rd amount is kind of hidden. The 10 centimeter circumference relates to the whole circle, to the full circle. And in a full circle, you have 360 degrees. It's a tricky one because it's not in front of your eyes that it's a 360 amount, but it is there nevertheless. So what is the arc length? Without doing fancy tangent, cosine, whatever operation with trigonometry, we can do it with ratio and proportion. Let's get started with 360, for example. The 360 angle is proportionate to the 45-degree angle, and we can write the 45 here or here. As long as we don't write it diagonally across, we'll be fine. And this again is a direct proportion, because the greater the circle, the longer the arc. So the 360 is proportionate to the 4, just as the 10 centimeter is proportionate to the arc length. Oh no, we ended up with an x down here. No problem, we'll flip it again. 45 divided by 360 and x over 10. We'll do it on a calculator. 45 will be divided by 360 and then multiplied by 10, and that will equal our arc length. Let's do this. 45 divided by 360 multiplied by 10 equals 1.25. It is 1.25 centimeters for arc length, figured out without trigonometry. So this concludes some of the sample calculations involving geometric shapes, triangles, circles, and we started with a rectangle in the previous one. The triangles relate to roof calculations and stair calculations, and the circle also relates to stairs and stair layout. I'm going to show you in the following videos some other applications.